you are going to need a ruler, so make sure you bring a ruler with you. As soon as you come in, just spread out and we'll get going, okay? All right, so today is the 25th, Chapter 3 review. And let's start with our chapter review, which is on page 211. Let's take a look at number 4. All right, so you want C, right? Okay. So the directions were tell whether the equation is written in slope-intercept form. If the equation is not in slope-intercept form, write it in slope-intercept form. So x is equal to 4y minus 1. All right, so we are comparing it with slope-intercept form. Ashley, what does slope-intercept form look like? No, that's direct variation. Y equals mx plus b, exactly. So is this in slope-intercept form? No, because I have x equals. So we want to turn this into slope-intercept form. So what I need to do is I need to do whatever I need to get my y alone. So I'm going to add 1 to both sides. So I get 4y is equal to x plus 1. And then, Ashley, I'm going to divide everything individually by that 4. So I get my y alone. So I have y equals 1/4 times x plus 1/4. Yep, absolutely. All right, so that's 4. Our next one was 18. So 18 said graph the equation. Who asked me for 18? Okay. So 18 gave us 4x minus y is equal to 3. And it's graphing slope-intercept form. So I need to turn this into slope-intercept form. So I'm going to do adding the opposite on this first of all right away. So I'm going to add a negative 4x to both sides. So I get negative y is equal to a negative 4x plus 3. Well, I don't want a negative y. I want a positive y. And this is like, it's like a negative 1 times y. So I need to divide all the sides by negative 1. So, or every term. So I have y is equal to a positive 4x plus a negative 3. All right, and now from here, I need my slope, which is 4 over 1. And I need my y-intercept, which is 0, negative 3. Please make sure you identify those. All right, and now I'm going to graph that. All right, so I have my y and my x. So I have 0, negative 3, which is right here. I'm going to go up 4, 1, 2, 3, 4 over 1. Up 4, 1, 2, 3, 4 over 1. And then I'm going to draw a line through that. You guys cool? Always state what you're using to graph. So if it's direct variation, you're stating your a value and then the point that you're using to go with that. If it's slope-intercept, you're stating your slope and your y-intercept. Does that help you guys? Awesome. All right, let's take a look at number 21. Okay, 21 said one athlete can run 60 meters at an average rate of 7 meters per second. So we have two different runners. So we have number 1. My distance is going to be negative 70 plus 60. This is for number 1. And number 2, my distance is going to be negative 60 plus 60. All right. It says the distance, D is the distance they have left. So D is the distance left in a race, which makes sense. Because if it's distance left, these right here, negative 7 times t and negative 6 times t, that's our actual distance that we've gone, and we need to subtract it off of the total distance of the race. Just so we can make sense of this answer. Rita, you're paying attention to what I'm doing, sweetie. All right, so we're taking our actual distance that we've done after amount of time, and we're subtracting it off of the total distance of the race. That gives us a distance left. Okay, so then it says graph both models on the same coordinate plane. About how many seconds faster does the first athlete finish than the second? Who asked me for 21? Okay, do you need me to graph it for you? Just kind of walk through it? Okay. So, well, first of all, to graph it, I'm using slope-intercept form. So I'm going to graph my slope, I'm going to graph my y-intercept, and then use my slope. Are you cool with that? Okay. So they're telling us about how many seconds faster does the first athlete finish the race. So Rafaela, if I'm looking at my graph, understanding what the information stands for is the most important part. T is my number of seconds I've been running, but D is my distance left. So if they have finished the race, how much distance is left? Raphael, if they have finished the race, how much distance is left? None. It's 0. So it's going to be down here on my x-axis. So here is my time that it took each of them. So it took the first person, it took the person that's running 7 miles per hour to finish the race. It took them about 8.5 seconds. The person that was running 6 miles per hour, it took them about 10 seconds. And this is about. To find how much faster one was from the other, you take just the difference between these two times. Does that make sense? Yeah, absolutely. Okay, so that was 21. All right, if we take a look at 23. All right, 23, who asked me for 23? Okay, so for 23, the directions were, tell whether the equation represents a direct variation. If so, identify the constant of variation. All right, so I have x plus 2y is equal to 0. How do I know just by looking at this that it's direct variation? Just by looking at it right here, how do I know this is direct variation? Well, do you guys see this 0? Remember, if I compare slope-intercept form, y equals mx plus b, and direct variation, y is equal to a times x. Remember, our origin is our y-intercept. So these are essentially the same equation. Direct variation just will always have a y-intercept of 0, 0. So our b is 0. So this constant here is 0. You can tell already that that's going to be a direct variation. If this was a 1, we know it's slope-intercept because we're going to have a b value, a constant. All right, but to prove it, I'm just going to subtract x from both sides. So I have 2y is equal to negative x plus 0. I don't even need a 0. All right, I'm going to divide each side by 2. Y equals a negative 1/2 x. So this is direct variation. So my constant of variation, that a value is negative 1/2. Does that help you? Yep. They are the same form, right? It's just one will always have a y-intercept of 0. Yeah, okay. All right, 27. All right, 27 said, graph the direct variation. All right, so I have 4x plus 3y is equal to 0. Who asked me for this? All right, so first of all, Joseph, I have to put it in direct variation form. So I'm going to add a negative 4x to both sides. So I get 3y is equal to a negative 4x. I'm going to divide each side by negative 3. So I have y is a positive 3. Y is equal to negative 4/3 times x. All right, my a value is negative 4/3. Remember, this is y over x. So this actually gives me the coordinate point 3, negative 4. And we already know that it goes through 0, 0. So there are my 2 points, and I would just graph those. So the important part was for you to remember, a is equal to y over x. And that literally gives me that first coordinate point. Are you cool with that? Awesome. All right, 28. this is definitely a direct variation story problem. All right, so let's read why. It says the amount of snow that fell during a snowstorm varies directly with the duration of the storm. So amount of snow varies directly with duration of storm. That's how I would write it. The moment you see this varies directly with in your sentence, I would write it in this structure. Y varies directly with X. So I know my Y is my amount of snow. I know my X is my duration of my storm. And I believe they tell us that this is in hours. All right, so I've identified my variables. Y is my amount of snow, X is my duration of my storm. And then it tells us that in the first 2 hours, so after 2 hours, there are 5 inches. Well, my duration of my storm is my X. My amount of snow that fell is my Y. So there is my my one coordinate point that I need. And it says, write a direct variation equation, how much snow fell in 6 hours. So Y is equal to A times X. We know we can use that because it varies directly with. That's direct variation. We also know that A is equal to Y over X. If you don't remember that, just substitute your coordinate point into direct variation equation and solve for A. That's okay too. All right, so my Y is 5, my X is 2. All right, since this is actual data, this is 5 inches in 2 hours. I need to turn that into a unit rate. So that's going to end up being 2.5 inches per hour. So that's what my direct variation, that's what my constant variation means. So my equation is Y is equal to 2.5x. And then after 6 hours, well, that is my X. So Y is equal to 2.5 times 6, which should give us 15 inches. You guys cool with that? Okay. So I did a direct variation story problem. Compare rates of change. Okay. Do you guys remember this problem? Not that one. I don't like that one. This one. Do you guys remember us doing this problem? All right. We have 10 consecutive weeks of a community theater performs a play each Saturday evening for 10 consecutive weeks. The graph shows the attendance in weeks 1, 4, 6, so these are the number of weeks, and in week 1, week 4, week 6, and week 10. And it said, describe the rates of change. So the directions were, describe the rates of change with respect to time. All right, so we need to find the rate of change between the first week and the fourth week, and you would describe it. All right, so between the first week and the fourth week, well, we found our slope or our rate of change. We end up with, it increases 36 people per week. That's what I'm expecting you to be able to say is something like that if I give you one like this. You find that rate of change, remember it has to be a unit rate, and tell me what it means. So between the first week and the fourth week, we had an increase of 36 people per week. You know, between weeks 4 and 6, we had a decrease of 14 people per week, etc. So I would expect for you to analyze this graph and tell me what you know about the rates of change between them, the data. Do you guys remember doing this? Kind of? We'll go back to that. You might want to remember that. Just a little tip. Okay? All right. The next thing you guys, and that was from section 3.4. That was example 6 on page 176. We did that in our notes. Domain and range. We've done these relatively recently. Let me see if I can find them. So when we talk about domain and range, again, this is one that we did in our homework. So Ryan, I think you asked for this. All right, so this was a function of the number of wolves we have during the time period of 1995. It says the number of years since 1995. So there was not an end date on this. So it was just since 1995. So we used just 0, 1, 2, and 3, or 0, 1, 2 to kind of come up with a graph. All right, and then once we got our graph, we looked at our domain. Well, we were able to have 0, because that's the number of years since 1995 would be 0. And because I don't have an end, Ryan, to that, my domain would be x is greater than or equal to 0. Because any number of years since 1995 is a possibility. If I had said 1995 to 2000, it would be between 0 and 5, right? Okay. Here, because I only had 0 as my limit, then my range is going to be anything 7 or higher. If I had that 2005 on there, I would have used 5 as one of my x's, and I would have found out what the f of x was after 5 years, and that would have been my maximum on my range. Does that make sense? So that's the domain and range part of it. Okay? Be smart about the values you're using for your x's. So if you have an end as beginning and an end, you're finding both of those, and that's your range for your maximum and your minimum. Okay? All right. I know I'm going through this quickly. All right, so one of you guys asked, Maggie, I think you asked for slope if I'm missing a coordinate point. Okay, so I think this is what you're talking about, because we did this for direct variation, but we also did this for slope intercept. So I have something like, this is going to be ugly because I'm totally making this up. So let's say I have the point 2, 3, and the point x, 5, and I have a slope of 1/2. We want to find x. Is this what you're talking about? Awesome. Okay. So slope is equal to y2 minus y1 over x2 minus x1. All right, we still use this. Just leave the x in for whichever one you're going to call it. I'm going to call that second one my x2, y2, just so I'm subtracting from that x. So I would have 1/2 is equal to 5 minus 3 over x minus 2. And now I've created a proportion. So I have 1/2 is equal to 2 over x minus 2. And now just use your cross multiplication. So I have 1 times the quantity of x minus 2 is equal to 2 times 2. So x minus 2 is equal to 4. So x would have been equal to 6. So it's just using your slope equation a little bit differently, but just substituting what you know in and solving for what you don't. Are you cool with that? All right, you guys, we are finito. You have your test tomorrow. All right, pay attention to story problems, direct variation story problem. All right, the domain and range type story problems. Comparing two equations, like if they're parallel to each other, you have to graph them and compare them. The one like Rafaela had us go over, when you compare them and they're not parallel, you know, what is the difference between blah, 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 blah. I think we did one on a homework quiz with squirrels. All right, go back to those kinds. All right, those are the types of story problems you're going to have, okay? Beating up tables for direct variation. Don't forget that. Are you guys good? Okay, we're done. You guys are ready. I know you are. Hang on, I lost my mouse up there. There we go. Dude, your big head's in my way. There we go.